Hey, what's going on, guys? KIM-1 here. In this video I'd like to introduce an extremely early development stage version of my online KIM-1 emulator that is running in browser. So here on the left you see how it looks like. So I tried to make it look and feel as authentic as the original KIM-1 as possible, even though unfortunately I don't have one and I wish I could have one, but yeah. But anyway, the project goal is to provide as accurate emulation as possible, but again, because of the very early stage of the development, it doesn't yet support tons of features that the original KIM should have. So in this video I just want to demonstrate a proof of concept look and feel of this of the original KIM-1. So we're going to be inputting the program from the first book of KIM, which swaps kind of two values in the memory. And that's pretty much all that we're supposed to be doing here today. So as far as you've seen how the entire emulator looks like, I will now just want to maximize it a little bit. So just to focus on just to focus on the display on its own, like this. I think this should be just fine. So literally it's just an image, a background image, and the transparent buttons on it. And here I have the canvas element that just overlaps the display of the original KIM-1. Nothing special really. In regards to the software products that I've been using here, so it relies on the library. There is a library to draw the 7-segment LEDs. Originally, it was intended to draw the only digits, so I needed to adapt it a little bit. And also, the 652 processor emulator is claimed to be the cycle accurate one. So currently, this emulator is running at hopefully 1 megahertz. I've been making a video on that and demonstrating the clock rate along with this emulation. So probably later on when it comes to adding new features, I'll probably add some sort of a nerd stats here, so just to see like what's happening under the hood there. But anyway, without further ado, let's actually find the program to swap those two memory locations. Yeah, here it is. Yeah, but before I also need to set this the vector locations because otherwise it's not going to be working properly. So let's start the demonstration. So let's say we go into the address mode, and here we can type whatever address. So the leftmost 4 digits are responsible for the address, while the rightmost 2 digits are responsible for the data that is available at that address. Well, the emulator just skips those addresses that doesn't physically exist, and in the console it just gives me an error message now, even though there is no console. Trust me, that is happening. So let's say we go to the location 1C22. It's where the ROM starts when you trigger the reset. Currently reset doesn't actually work as well as the stop button, because the stop button triggers the non-maskable interrupt, and I'm not really sure what reset does apart of setting the program counter to this particular address. I still need to make a bit of research to make this real authentic sort of a behavior, but the rest of the buttons should be working as expected. So yeah, we need to set this before running this on any program. Be sure that you have set the contents of the KIM vector locations as follows. So we need to go to the address 17FA. So I'm going to 17FA, and here should be 0. Okay, then the next, and here should be 1C. So I'm going to the data mode, and now I can enter 1C. And you see, like at this address 17FB, we have the value 1C, and then go to address 17FE. There should be the value of 00, which it is, and then 17FF should contain the value of 1C. So go into the data and set in 1C here, and we are done. Okay, so now we can already start loading our program. Well, probably before that. So what this program does is swaps the values in the addresses 10 and 11, and in order to see the output of the program, we really need to set some sort of a values to those addresses. So go back to the address mode and let's go to 001010, and here let's put the value of 10. And you just remember that at the address 0010 hexadecimal we have the value of 10, and at the address 0011 hexadecimal we have the value of 11. Now I'm going back to the address, and the program will swap this. So the address of 10 will have 11, and at the address of 11 we'll have 10. So that's how we'll verify that the program was actually successfully completed successfully. Right? So now let's go to the address 0200, which is the starting point for our program to execute. So 200 is hexadecimal, and now we need to input these bytes. I'm not going to be diving into what exactly it does and how in particular. So I have like 6502 crash programming 6502 crash course, some videos on hand assembling the 6502 machine codes, and really lots of things like that. So it's not the scope of this video demonstration. So I will just input the bytes and run the program, and that's going to be fairly enough, I hope. So I'm going to the data mode here, and let's input this byte. So A5, and then next, and 10, and then next A6, and next 8, 5, and next 11, next 8, 6, next 10, and next 00. Okay, go into address. Let's drop back to the starting address and verify with it. Input the bytes properly. So 200 is hexadecimal A5, then should be 10, then A6, then 11, then A5. What? Whoa. So this is wrong. Okay, this is wrong. Go into data. So this should be 85. Okay, already a mistake here. Okay, so what have I done? Okay, let's start again. Sorry guys, I'm a bit nervous because this is the first time. Okay, so A5, 10, A6, and here go into data, and this should be 11. Next, okay, 85. Next, so this should be 11. Next, this should be 8, 6. Next, this should be 10, and this should be 00. Okay, going back to address 0200. Okay, A5, 10, A6, 11, 8, 5, 11, 8, 6, 10, and 00 break. So far so good, so it should be working now. So remember that at the address of 0010 we have the value of 10, and this would be changed to 11 after we run the program, and here instead of 11 we should have the value of 10. So let's go to 0200, and I hold my breath and let's go. So it stops at address 020A, which is the exact behavior that we should see there. Yeah, so it should stop at 020A. Okay, so far so good. So now to verify if the program actually worked properly or not, we can go, so pressing the address, go into 00110, and indeed we have 11 here, and here we have 10. So yeah, we just swapped the values in the memory. So nothing special so much, and probably not really impressive for most of you guys, but again, like for me personally, when I see this, I don't have a real KIM. I wish I could have one, but yeah, unfortunately I don't. And working with this emulator, which really looks like the real KIM, makes me so happy. So yeah, at least I can do this with my mouse here in the browser, and I hope that this is gonna be possible to be done using the smartphone as well, because it's really the web interface allows you to run this in whatever device that has the web browser, and hopefully the compatibility of the canvas element should be working nicely on whatever device as well, because these are just the buttons, so they should be working everywhere. So yeah guys, this is it from my side. I hope you've enjoyed the video, and I'm going to be adding lots of features and debugging things, and again, like the original idea is just to make it as accurate as possible. I don't yet have timer being implemented here, so that's another thing to bear in mind. And I'm going to be making another videos on So this is just one of many progress videos on this project. But now, after this video comes out, you would already be able to finally try to play around with this KIM-1 emulator on your side, because I'm going to publish this today, basically. So yeah, feel free to play around, and really wondering what are you guys thinking about this project. So please let me know in the comments. This is it from my side. Thanks for watching. Until the next time, and take care.